Welcome to our video lesson over quadratic equations. Go ahead and bring up Desmos and we will get started. What is a quadratic equation? A quadratic equation is when we have x squared, but we also don't have any larger exponents. In general, a quadratic equation is of this form right here, where we have it equal to 0. That's kind of an important idea. If it's not equal to 0, it's just not in standard form, but it could still be a quadratic equation, so long as we have an x squared term. Ax squared plus bx plus c. Now, we recognize this as a quadratic trinomial. We've factored these, and so we've already been dealing with a quadratic equation, but this is just a nice little refresher. A, of course, cannot be 0. If a was 0, we would not have an x squared term. But b and c can totally be 0. We do not need a term with just an x. We do not even need a constant term. But we need an x squared term to make it a quadratic. In today's lesson, we're mainly going to be talking about the solutions to quadratic equations. Now, solutions in general can also be called zeros. It's where y is 0. It's the x-intercept. It's also known as the root. These four words right here, solution, 0, root, x-intercept, all mean the same thing. The solutions of this quadratic right here that has been graphed are -1 and 6. That is where y is 0. Note that these coordinates are -1, 0. That's this coordinate right here, this x-intercept. And this coordinate right here is 6, 0. So our solutions here are x equals -1 and x equals 6. Let's take a look at this example. I'm not going to delve right into Desmos for this one just yet, but we will get there. We have a function. It is a quadratic function, and it is in standard form. And if we wanted to find the solutions, we would just graph this on Desmos and see where does it hit the x-axis. Do not worry about this right here. We'll get there in just a moment. But where we hit the x-axis is here at -2, and then here at -1. So our solutions are -1. I'll put them actually in order here from least to greatest, -2 and -1. And if I accidentally said them wrong when I was just explaining, my bad. But we cross the x-axis at -2 and -1. Those are the solutions. They are x equals those values. Now, to revisit a topic, let's talk about domain and range. The domain of every single quadratic function, every single one, is all real numbers. So all reals. We can also write this as -infinity to infinity. We can plug in any x value we want. Remember, domain is the x value. We can plug in any x value we want here. This graph extends indefinitely to both the left and the right. Yes, it's also going up, but it takes on every single horizontal x value. Okay, next up, the range. I'll keep those arrows here. The range is the y. We can see that we do have a lowest point on this function, our minimum value. Our minimum value, or our vertex, occurs right down here. The vertex is the turning point of this parabola. In this case, our vertex is a minimum point. It's all the way at the bottom. The y-coordinate down there is -0.25. I just clicked on it on Desmos. So our range is every y value greater than or equal to that -0.25. Because our function only goes up from that point. There is no y value, there's no graph below that y value of -0.25. Now, sometimes it's written in this kind of funky, fancy way where we have a y and then a little vertical line there. This is just saying our range is all y values such that y is greater than or equal to -0.25. You only care about this part right here when building your range. You could just write this part right here, but sometimes on the SOL or benchmark exams, it is like written like this. Okay, let's try one out here. Go ahead and pause for just a moment to enter this into Desmos just as is. Now, can you use N? I shouldn't have said as is. You need to use X. So replace the N's with X. Go ahead and do that now. Okay, so you should have it in Desmos. What I want to do is actually take a look at it as well. Okay, so I have a couple things here. I don't want them all to be graphed. Just ignore the things that are not highlighted. So we can see that we have this quadratic in just as is. Of course, I need to use X instead of N, but I put it equal to -6. So this is still a quadratic equation. It's just not like super simplified. It's not in standard form because it's not equal to 0. And so as far as we zoom out, as far as the eye can see, right, I don't have a parabola. I just have two solutions. Well, those two solutions here are where we're hitting the x-axis. Our solutions are going to be -6 and 3. You just have to look where you hit the x-axis. Now, if we think about how can we actually solve this so that it equals 0, to actually look at what the parabola looks like. In order to get this to 0, I need to get rid of that -6 there. I want that to be a 0. So we need to add 6 to both sides. We're going to add 6, add 6. You can only add it to just the regular constant term. Like terms only can be combined. And then we see we have this equation equal to 0. Now, I'm not going to type the equal to 0 part. It's just -x squared minus 3x plus 18. That's how it's now in standard form. We just shifted that -6 over so that we had just an ax squared plus bx plus c. Let's go ahead and graph that and see what that looks like. We can see that that is the blue. I'll change it so that it's a much different color. We'll make it bright red here. And so we can see as I zoom out, I can see my parabola, -x squared minus 3x plus 18. That parabola opens down. It opens down because our leading coefficient is negative out front, negative. We can see that the solutions are, of course, -6 and 3, where we're hitting the x-axis. The same values that we got from just plugging it in as is. But if you'd like to see the actual parabola, you need to make sure it's in standard form like that. No equals anything. We can see that we have a maximum value here of 20.25. So let's write out what our solutions are, our domain, and our range. So our solutions, we said, are where we cross the x-axis. X equals -6 and x equals 3. Then our domain, the domain of any function, any quadratic function rather, is all real numbers. Finally, our range, we need to see what our vertex is, our maximum value. The y value at the very top is 20.25. Everything else is beneath 20.25 for y. Our entire graph exists below that y value. So our range is going to be all y values that are less than or equal to this y value of 20.25. Again, here's where we got that. That was 20.25. So that was our solutions, our domain, and our range. Again, if you do not need to find domain or range, and you simply want to just plug in what you were given, if you do so, you will still just look to find the solutions are where you hit the x-axis, the x-axis. Okay, going back to our next problem here. This is our last problem. We have x squared plus 49 equals 14x. Take a moment to also put this into Desmos. Note that this again is not in standard form. It's not equal to 0. We have stuff on both sides. So looking here, we can see I put my function in, x squared plus 49 equals 14x. And we see that even as much as I zoom out, it only looks like we have one solution. I wonder why that is. The solution is 7. But quadratics usually have 2 solutions because they hit the x-axis 2 times. Let's see why that is. I'm going to solve this for 0. So it looks like we have to get the right side equal to 0. So we're going to subtract 14x on both sides. Now an x term is not a like term with either x squared, nor is it a like term with 49. So instead, we're just going to smush that minus 14x in between those 2 terms there, because that's our like b term. And then, of course, it equals 0, but all we need to plug in now is x squared minus 14x plus 49. Take a look at where this graph, and we'll make it nice and bright red here. Let's take a look at where this graph crosses the x-axis, its solution. It hits the x-axis at 7. That's what we said our solution is. However, it just sits on top of the x-axis and then goes back up. It doesn't cross it, so it's not going to have 2 solutions. It's not going to hit it twice, only once. This solution it actually occurs twice. We say it as a multiplicity of 2, but we just say that the solution is x equals 7. That's all. This is actually what's called a perfect square trinomial. If we think about how this is factored, it's factored as x minus 7, x minus 7. So the same factor occurs twice. X minus 7 occurs twice, and therefore positive 7 is our solution. We only have one solution. Okay, so hopefully you enjoyed our video today over quadratics. I hope you learned a lot and did well on the Playposit. See you soon.